family. Let's look at this question on statistics, right? They say F1 race car drivers have to endure high G-forces at extremely high temperatures, and they tend to lose close to 4 kg of weight after every race. The table below shows the total weight lost by 40 different race car drivers after the duration of one race. Okay, perfect. So now guys, they give us the table here, right? They give us the table here. Let me just get my pen quickly. Okay, I don't need that color. Let's put red. Perfect. Sharp. So the table just analyzes what summarizes the information provided on the scenario there, right? Perfect. Now let's go straight to the question. Write down the modal class. Okay, modal class, remember mode is the most occurring, right? Perfect. So the modal class is easy to get. You just check the interval, the class or the interval with the highest frequency. So I can see that 15 is the biggest frequency here. So this will be my modal class. So the answer for this question is SW, ne? W. Then 3,000. Sharp. We are done with that question. Now they want us to calculate the estimated mean, ne? The estimated mean weight. Okay, there's a step that we do to calculate the estimated mean weight, ne? So estimated mean, right? Just follow me. What do? You do this. You take these two numbers here, you add them, right? Then you divide by 2. What will be the answer? 0 plus 500, it's 500. Divided by 2 is what? So when I say 0 plus 500 equals to 500. Divided by 2 is what? Is 250, right? Then the answers that you get, you're going to multiply with the frequency, ne? This is what? 1.5 divided by 2 is what? 750, right? I can see that I'm adding 500. So what do? You have 250 plus 500 gives you this part, 750, right? You're going to say 750 plus 500 will give you this part. Right, and then you keep on adding 500. So this part is 1. Just press 500. This part gives you that, right? You're gonna multiply all with frequency, ne? And this is what? 2750, right? And the last one is what? 3250. Sharp. Multiply. So what you do now is this. To calculate the estimated mean, you're gonna say 250 times 1, which is what? Which is 250, right? Plus, times 1, and then 750 times 2. So you just add everything here, basically. That makes sense. Plus 1250, 3, plus 1750, 8, plus 2250, 6, 2750, 15, plus 3250, then 5, right? Then okay, so and then whatever you have there, you're gonna divide by the total frequency, né? Whatever the sum you have, you're gonna say over the total frequency. So now let's check. So we're gonna say let's type it down on our calculators. We're gonna say 250 times 1 plus 750 times 2 plus 1250 times 3 plus 1750 times 8 plus 2250 times 6 plus 2750 times 15 plus 3250 times 5, then all over 40. I get, this is my answer for the estimated mean, which is 2260. 3 marks there. And now let's go to this question. Question 2.2. The recording of the weight lost in a second race was made a month later. Right? So which means that these recordings here were made when the weight was already lost of the athletes. Right? The amount of weight lost in race 2 was kilograms more than in race 1. It is given that the maximum value of the Ogaev was that, and the minimum was that. Because of 0, it was the minimum. Remember, guys, before we can draw an Ogaev curve, we need what? We need a cumulative frequency. It is also called cumulative frequency. Sometimes they won't say draw the Ogaev curve. They'll say what? Draw the what? The oh, they even did here in bracket. You see cumulative frequency graph. Right? And so which means we need cumulative frequencies then. We need cumulative frequencies. Okay, let's quickly get our cumulative frequencies. So I'm gonna add a column here for cumulative frequencies. Okay. I'll just say cum freq for cumulative. So cumulative frequency, remember, we get this plus 0 is that, right? This plus that is 3. This plus that is 6. This plus that is 14. This plus that is 20. This plus that is 35. This plus that is 40. Right? Perfect. So now we can easily sketch, ne? Remember, we are told that we are told that 0 when y is 0, when x is 4, y is 0, right? We're gonna start with that. Is the starting point. There is it. You see, when x is 4, y is 0. Now we go back to our thing. Let's check. Then now this number, say this is basically 544. 544 goes with 1. This goes with 3, and so on and so on. Right? If you check, this one goes with 1. You see it? That one is on 3, and so on, and so on, and so on. Right? And if you check, it is true because this part, right? This number here will go with 40. You see? Yeah, you just keep on adding 4s, and because remember, this was recorded when the weight was already lost. But the good thing is the graph paper already gave you these values here. You just plot, right? You just plot, and done. Okay, perfect. Then what does the next question say? How will a range of race 2 compare with a race of range 1? Oh, the range will remain. They will remain the same, guys. Remember, remain the same. Why? Because the amount of if you subtract this from that, you'll see that the answer is the same because the amount of weight lost is constant. It's like 4 kg every race. It doesn't change. You get it? So the range will be the same. Determine the average weight loss in race 2. So this was the average weight loss, right? So in race 1, this was what we are starting with. This is the approximate mean. So in race 2, we have to add an average of 4 because each and every race is going to lose what? A weight of 4. So we add 4. So the average weight loss is what? Remember, average means mean. The reason why I took mean is because of the weight. Average means mean. So mean weight loss. So whatever the mean was initially, I add whatever the weight loss average is. Right? Perfect. 2266.5. Then we're done with this question. Thank you very much, ladies and gentlemen.